I hope all of you are doing well this morning. I am Mr. Ish. We have to find the area enclosed by that equation that you see, 2x squared plus 4x plus 3y squared plus 6y equals 1. When you're looking at an equation like this, you have to complete the square and bring it into a better form. You're going to start by isolating 2, and then you'll have x squared plus 2x. Then isolate the 3 from the y variables. You'll have 3y squared plus 2y equals 1. Complete the square. 2x squared plus 2x plus 1 plus 3 into y squared plus 2y plus 1 equals 1. 1 times 2, 1 times 3, well, plus 2 plus 3. Now look what you have over here. 2 into x plus 1 whole square plus 3 into y plus 1 whole square is equal to 6. When you have an equation which is in some form x square plus y square equaling to 1, then you know you're thinking about a circle. But when you have an equation, you have some number over here. I'll just put this as a symbol, and let's make some modifications. You have a coefficient which is here, a coefficient over here, then you're looking at, with the plus sign, an ellipse. That's what you have. So you have to see and understand these differences. This right here clearly tells you there's an ellipse involved, because when you take the 6 on the other side, make everything equal to a 1 by dividing everything, you can have coefficients involved, and you're looking at major axis and you're looking at minor axis, the transverse axis, the minor axis, all of that, which you don't see in a circle. Because in a circle, when you look at any type of chord going through the center, all of these are diameters, and in any direction the diameter is equal to diameter. When you have an ellipse, you have a major axis and you have a minor axis, and they're going through the center, but these various axes are not equal to each other in terms of dimension, hence the ellipse versus a circle, hence the presence of coefficients. What you have to do now is divide everything by 6. We'll do that, and then it'll bring us into a form which you will be familiar with. X plus 1 whole square over 3 plus y plus 1 whole square over 2 is equal to 1. You have everything here in the standard form like this. X minus h whole square over a square plus y minus k whole square over b square is equal to 1. You know, just by looking at this, a square is equal to 3, therefore a is root 3. B square is equal to 2, so b must be equal to root 2. If you think about an ellipse, c square is equal to a square minus b square, then you know c here is equal to 3 minus 2 and the root of that, which is 1. The minor axis endpoints, the vertices, the focal points, you remember all of that. What's the center of this ellipse? When you're looking at x plus 1, y plus 1, you have a center, minus 1, comma, minus 1. That's what we have. If you were to graph it, you can do a rough graph. Minus 1 comma minus 1 is right over here. The vertices will be along a horizontal direction. It will be minus 1 plus and minus root 3 comma minus 1. You'll have 1 point here, 1 point here. I'm just estimating here only. What will be your focal points? It will be minus 1 plus and minus 1, and you know that to be case. Minus 1 plus and minus 1 comma minus 1. You clean this out, you're getting here a minus 2 comma minus 1 as one focal point, which will be somewhere right here, and you're getting here a 0 comma minus 1, which will be right over here. What about your minor axis endpoints? We can bring in the minor axis endpoints. It's going to be in a vertical direction from your center. Your minor axis endpoints will be minus 1 comma minus 1 plus and minus root 2. 1 point can be roughly over here, 1 point can be here, and then you're looking at your ellipse and it looks something like this. Now we're interested in the area of this. I don't need to show you this anymore because you've seen it. But look, the area of an ellipse is not hard by any means. Area is equal to pi AB. What's my A? What's my B? Root 3 times root 2 is a root 6 times pi, and it'll be a root 6 pi will be the area of this. Consider this very last item. Eccentricity is equal to c over a. The deviation of this ellipse from a round circular form represents the eccentricity of an ellipse, and it's always a value from 0, larger than 0 but less than 1, never including the value 0 or 1. What's the eccentricity over here? It'll be 1 over root 3. You can do a calculator value and you'll find out it's come somewhere over here. It's an eccentric ellipse. Keep in mind, an ellipse differs from the circle by means of this deviation from the circular form, hence you have an eccentricity. A circle has no eccentricity because it's circular. Anything which deviates from a circle, like a hyperbola or ellipse, will have a certain eccentricity which a circle does not have. But the question here was area is equal to what? It's root 6 pi, pi AB, pi times root 3 times root 2, which is root 6 pi, and we're done. Thank you. Have a good day.